Welcome back to another Lettuce Garden scripting tutorial. This is actually the first video of a new series for a new force system that we're releasing. Over the next 3 videos, we're going to learn how to make a force push, pull, and choke. And then the following week, we're going to release videos on creating the UI and the rest of the framework, as well as setting us up to add in even more force powers in the future. So we're going to make a force lightning, for example, a force healing, and I'm really open to your suggestions to hear what else you want us to make. But yes, this week we're going to focus on force push, pull, and choke. So I'll show you guys what those all look like. So here's our force push. We lift up our arm and push all of our characters away. Our force pull, we can pull players towards us. And for our force choke, oops, that's the wrong button. For our force choke, when we hold down the button, players will lift up into the air with their arms around their neck, and you can force choke them. So over the next 3 videos, we're going to learn how to make these 3 powers. The following week, we'll look at some more. If you want the content for any of these, like the source files, check out the link in the description to our website. And if you want help, check out our Discord server. The first thing we're going to do is set up the local script that is going to control our user input detection and then send events to the server. So let's make a new script in starter player scripts, local script. And we're going to use context action service to detect the inputs because that also allows us to add Xbox and mobile support right away. So let's import context action service. Context action service equals game get service context action service. And then we can do here, we can make a table of all of our force powers and keybinds. So over the next 3 videos, we're going to be doing push, pull, and choke. So we can set up the keybinds for these right now. So local keybinds equals table. And then we can say push equals, we're going to make another table here. So enum.keycode.e and enum.keycode.dpad_up. So basically what we're saying here is we want to activate the push force power when the user clicks E on their keyboard or up on the Xbox D-pad. And we can set these up for the pull as well. So enum.keycode.q or enum.keycode.dpad down. And then for the choke, we can do enum.keycode.c and enum.keycode.dpad. Right. Now, these key codes can be whatever you want. They're fully customizable to be whatever you want them to be for your game. I'm just using these for this video. And now that we have these created, we can now loop through all of them and set up the proper keybinds. So we can say here, for name keybinds in keybinds, do. And I can say, I'm going to change this actually to power keybinds so that we're not using the same variable name. And then here we can say context action service, bind action. We can give the action a name. In this case, the name will just be the force power we're using. We also have to give it a function to call, so we can just name this function for now, activate power. And true, so that we create a mobile button. And then table.unpack keybinds, or sorry, power keybinds. So with context action service bind action, the way the function expects us to give the keybinds is just an infinite list basically of just any keybinds we want to be associated with that event. So I can go on forever just adding keybinds. What table.unpack does, so table.unpack power keybinds, it takes our power keybinds that we set up in this variable here, and then turns it into that format so that this function can interpret our keybinds as that really long infinite list of keybinds. And so we said here we have to make a function called activate power. So let's make that local function activate power. And when this function is called, we're going to get the power name, and we're going to get the user input state. Now you also get the input object here, but we don't need that for this. And what we're going to do here is we're going to say if user input state equal enum.user input state.begin, then print start power name. Else if user input state equal enum.user input state.end, then print end power name. So when you press down on the key, so when I press down on E, for example, it's going to print start push. And when I let go of E, so when I lift my finger up, it's going to print end push. Now for some of these force powers, it's not super important to detect the end. But for example, with the choke force power, we're going to implement that so that it only chokes the player while you're holding down the key. So this will become important for the choke, but for the push and pull, it's just going to be one pulse when you hit the button. So for these, only the start is important. However, the system that we're building will support both types. So we're going to keep the way it is for now and change it if we need to, but yeah, this will work for now. Now with context action service, when we run the function, we also have to return here enum.context action service, context action result.sync. And what this does basically is if you have multiple things in your game all associated with this E keybind, for example, if activate power is the newest one or most important one in this current context, what sync will do is it will stop it from activating all the other events as well. So if you have like 3 things attached to the letter E in your game, you don't want all 3 to run every time you click E. You only want like the most important one to run, right? So you can return sync. Now, if you did want multiple to run, you can write pass, and then it will run the functions for every context action event that's associated with that keybind. I know that might not make a lot of sense. However, we do want to, just for this system, we want to return .sync. Okay, so we can test this out now. I'm actually going to rename our local script here to force client. And we're going to head over to our test mode. And basically, anytime I hit E, Q, or C, I should be getting prints in the output. So if I hit E, it says start push and end push. So when I hold down E, it says start. When I let go, it says end. Same thing with Q and C. So our client script is working properly. So now we can go up to the server and do something with these events that come through. So let's make a new script. We'll call this force server. And the first thing we're going to do is set up a remote event that fires when we get when we press something on our keyboard. So in replicated storage, let's add in a new remote event. We'll call this force event. And in here, what we'll do is we'll reference this event in our server script. So local force event equals replicated storage dot force event, and we get to import replicated storage. And we can also do this in our client script. So let's go back to our force client and let's import replicated storage equals game get service replicated storage. And rather than printing start and end, we're going to tell the server that we want to start and end. So we'll remove this and replace it with, let's actually make a variable first for our force event. So force event equals replicated storage dot force event. Then here we can do force event fire server start power name. And then here we can do force event fire server stop stop power name. And now on our server script here, we can listen for when these events fire. So force event on server event connect. We get the player, we get the request type, and we get the power name. So now we can print here, player wants to request type power name. Okay, so let's recap what we did. Now in our force client, rather than printing start and stop, we are firing an event to the server with start and the name of the event as our parameters. On the server, we're going to listen for when the event fires. We get the player, the request type, and the power name, and we're going to print that out just to make sure everything is working properly. So when I hit E, prints on the server. So when it's green, it's on the server, blue is on client. So green's on the server, and it's printing as I hit different buttons on my keyboard, as we want it to. And now that we have the server side of this detecting our input, we can start actually making the force powers. Inside of our force server script, let's make a new folder, and we'll call this powers. And then inside powers, we're going to make a new module for our push power. Now remember, we're making this system in a way that's expandable and infinitely scalable. We want to be able to add new force powers to the system all the time. So we're going to split this off to be a very modular system, so it's really easy for us to add new powers in the future. And for this video, we're going to start with the push power and build out the framework around that as well. So we can delete everything in here. We're going to write local force push equals an empty table. Force push period double underscore index equals force push. And then here we can do function force push dot new. Then we're going to return force push. All right, so what we're doing here is we're doing something called object-oriented scripting in Lua. Now, compared to other language, Lua's object-oriented programming is very interesting. Is the word I'm going to use. But this is how we can set it up. So basically, what we're going to do is every time the player starts using a new power, we're going to call this dot new, and then we're also going to give the option to call a force push on update and force push stop. And basically, what's going to happen here is every time we create a new force power on the server, we're going to call dot new. Every frame it's active on update will get called, and when we want to end it, stop will get called. So what we can do here is we can finalize setting up our object. So local self equals set meta table empty table force push. And then here we can return self. And here we're going to pass in two things. We're going to pass in something called player and on finish. So the player is the person who's actually doing the force push, and on finish is a function that we're going to call when we're done doing the push. So here we can set self.player equals player, self.onFinish equals onFinish. We actually also need to call start. So we need a force push start as well. So the framework we're going to build is going to expect every force power we make to have a dot new, start, on update, and stop. And then we can write code within these to do stuff. So here, let's just for now print start, print on update, and print stop. And then here we can print created. All right, so let's go back to our force server script and write out the framework that's going to run all of this. So let's make a new function here called local function get power. And we're going to expect a name and a player. And here what we'll do is, let's make a new variable here, local powers equals script.powers. We're referencing the folder. And then here we can say local power module equals powers find first child name. Let's rename this to be power name to keep it consistent with the rest of our code base. And then here we can say if not power module, then warn power name does not exist and return. And then here we can say local new controller equals require module, require power module, sorry. Call.new, we're going to pass in the player, and then we're going to supply that on the finish function that we just talked about. So local function print finish was called, and then here we can return new controller. Okay, so basically what we're doing here is we're getting the module that contains our force power. If it doesn't exist, we're going to warn that in the output. If it does exist, we're going to require it and call the .new. We're going to pass in the player and the onFinish function. So remember here we have player and onFinish. So we're passing both of those in here. And then we're going to return new controller. And what we can do here now in our force event on server event, we can say if request type equals start, then we can get the controller. Local controller equals get power. We have the power name and the player. And then, okay, so this actually gets our power, right? So now here we have the option to now call controller start. So remember here in our force push, we have start on update and stop. So right here, we're connecting the start. And we'll connect the stop and on the update later. But for now, what we're going to do is we're just going to call start. However, we want to make sure that if the player spams the hotkey multiple times, we don't create multiple instances of a force push, right? We don't want the player to be able to have like 5 force chokes running at the same time. That doesn't make sense, right? So we need to track if these powers are currently being used. And if they are, we want to not create a new one. So we can create a new table up here, local active controllers. And here what we can do is we can say active controllers player equals active controllers player or an empty table to initialize it. And then here what we can say is in the onStart, we can say if active controllers players power name, then warn power name is already active and return. And then here, after we call, right before we call start, we can say active controllers player power name equals controller. So now what we're doing is we're checking to see if the player has a controller with that power already enabled. If they don't, we're going to create a new version of it and assign it to their active controllers table and then call start. Now, because we're doing this, we need to make sure that we also clean things up when we're done, like when the player leaves the game. So we can say here, we're going to import players. And then down here, we can say players.player removing connect. We get the player, local active controllers. We'll name this player active controllers to prevent the naming conflict. Equals active controllers player. If not player active controllers, then return. So this will run if the player has never used a force power, then return. If they did, then we can loop through all of them. So we can say for underscore controller in player active controllers, do controller stop, and then active controllers player equal nil. So we're going to stop the controller, and we're going to set the player active controllers to nil so that it's not taking up memory after they've left the game. Using this very similar method up here in the onFinish, what we can do is we can say active controllers player power name. So local controller equals that, and then we can say if not controller, then return controller stop. And in this case, because the player isn't leaving the game, we have to set active controllers player power name equal nil, so that we can run a new event after this one is finished. All right, so this is a lot of framework stuff, and it might be kind of hard to follow. So let's test this out and see what's going on when we click buttons. Okay, so we don't get any errors. That's a good sign. If I click E, so if we look at our force push thing, remember we said print create and print start when we create and call start. So we get that. If I click E again, it says push is already active. So I'm not able to start another force push because we haven't told the system that we finished the previous one. All right. Now I can start. Oh yeah, sorry. And if you try to do the force pull or choke, you're going to get errors because the controllers, we haven't created those yet. We're going to create those in future videos. So in this video, only the push is going to work. Okay, we can clear that output. And now what we'll do here is we'll actually write out the force push power. Now this can be a little bit challenging to test in a development environment because we're pushing other players, right? And right now in our development environment, it's just us. So we're going to kind of fake other players. We're going to go to the Avatar tab and click Rig Builder. I'm just going to import a few kind of dummy models. So on this first one, I'm going to go up to my tag editor. So in the View plugin, or the View tab, sorry, I can open up the tag editor. I'm going to create a new tag called character and assign that to my rig by hitting the checkbox while my rig is selected. And now I'm just going to copy and paste this a few times. So I have a couple of testing characters here to push around. And inside of our force push now, what we'll do is in our start, this is where we're actually going to push the players. First, what we're going to do is we're going to detect the players that are in front of us. And actually up here in our constructor, I'm also going to set self.character equals player.character because we're going to use that quite a lot. And so we can say here local character pivot equals self.character get pivot. And then we can loop through all of the characters in our game. We're going to have to import collection service for this. Local collection service equals game get service collection service. Local characters equals collection service get tagged characters. We're going to write a comment here, temp while developing, because when we actually want to use this in a live game, we're going to change this up slightly. But for now, this is what we want. And then we're going to loop. So local underscore enemy character and characters do. We're going to get the character's root part. So local enemy root part equals enemy character dot primary part. Local distance equals character pivot dot position minus enemy root part dot position dot magnitude. And then we only want to affect, our force push only wants to be, we want to restrict it to be a certain distance in front of our character. So we can set up a new constant up here, local push. Actually, we'll say local detection distance equals, we'll do 40 studs. Then here we can say if distance is larger than detection distance, then continue. Else, we're going to get a vector towards the enemy. So local vector towards enemy equals cframe dot look at character pivot dot position root part enemy root part dot position dot look vector. All right, so now we have a vector from our player to our character, to our enemy, and we want to determine if that enemy is standing in front of us. Because if the enemy is in front of us, then we want to push that player. So what we can do for this is we can say here local relative cframe equals character pivot to object space enemy root parts dot cframe. Actually, we actually don't even need this vector towards enemy. We can just use this relative cframe, and then for now we're going to print relative cframe out and see what happens, because I want you guys to see what prints when we click this button. So if I go back to my test mode and walk up to all of these dummies, if I click E, oh, actually nothing's printing. Let's check that out. That's because I made a small typo here. The tag that we're getting is character, not characters. We don't have anything in our game tag characters. So now when I walk up to these rigs and I click E, primary, I made another typo. Primary parry. Should be primary part. We'll test this out again. Click E. And that's another small typo. Rather than two objects, it should be two object space on line 33. Hopefully this time it works. We're getting further and further every time. This is how coding goes sometimes. You just go from one error to the next. All right, so we're getting things printing this time. Just a bunch of numbers. However, what's actually printing here is a C-frame. And what we can see here is all of these have negative 0.983. Okay, keep that number in mind. This time I'm going to turn my character around. I'm going to do a 180, turn my character around, and then click E. This time it's printing positive 0.99. So what we can say is if the number is positive, we're facing away from them. If it's negative, they're in front of us. So what we'll do is if relative cframe dot z is less than 0, then print push. So if that number is negative, if the z element of our cframe is negative, then we want to push. So let's test this out. When I look towards the dummies and click E, we get a whole bunch of pushes happening. So we get 10 pushes printing, which is exactly what we want to see. And just so we can start testing multiple times in the same session, at the very end of our start function, we're going to call self.onFinish so that the system cleans up the force push and we can do it multiple times. So let's actually test that out. Let's test out our onFinish functionality that we wrote earlier. I click E. It prints push and it prints stop because remember we're calling that stop function, and it lets me keep pushing now. I can do multiple force pushes now, and it's not going to restrict me. All right, cool. So now let's actually program the actual pushing of the player. Now I made a mistake. We actually do need that relative. That's the vector that's pointing towards our enemy. So we're actually going to rewrite that line out, but down here, local vector to enemy equals cframe dot look at enemy root part dot position. Actually, sorry, I meant to say character pivot dot position, comma, enemy root part dot position dot look vector. And then here we can say the force that we want to push this player is local force equals root part, enemy root part dot assembly mass times workspace dot gravity divided by 1.5. All right, let me explain this line out a little bit. So in order to make sure that this force push works on any object, we need to take into account the mass of that object and the gravity. And now in this case, we're only going to be pushing players. However, we want the effect to be consistent on players who are maybe super tiny in your game or super large, wearing very heavy armor. We want the effect to be the same on those players. So we take the assembly mass, and the assembly mass is basically the mass of all the objects that are attached to our root part. And then we multiply it by the gravity because we need, in the physics world, force equals mass times acceleration. And in this context, mass, we already have here, assembly mass. Acceleration is the acceleration due to gravity bringing the player down. And I did some testing with this earlier, and I found that if we leave it like that, the force is way too powerful. So I divided by 1.5 to get a better result. You can change this 1.5 number if you're not happy with the way it comes out, but it works really nicely, in my opinion, for this. We also need to determine the vector that we want to push the player along. So local vector equals vector to enemy. And then we're going to just, if we push directly towards the player, they're just going to drag along the ground. So we actually want to bring this vector up into the sky a little bit. So we can do vector3.new 0, 0.5, 0. We're going to put parentheses around all of that and convert it to a unit vector. And now a unit vector is just a vector that has a length of 1, which is important because in the next step here, root part apply impulse vector times force. And sorry, enemy root part apply impulse. Now, if we didn't convert this to a unit vector, this force calculation that we did here would be messed up because it expects the vector to have a length of 1. So after adding additional length to our vector, we need to convert it back into a unit vector so that the impulse is consistent. And we can actually test this out now. If we walk up to our characters and click E, they get pushed. So we have a working force push system. Now I think our range is too big. So let's go back to our push. I'm going to reduce our detection distance to 20 and test this out again. Now when I walk up to the characters and click E, they get pushed. And only the characters that are within our detection zone are getting pushed. So that's our force push. In the next couple of videos, we're going to go over how to do a force pulling system and a force choking system. Then we're going to go over adding animations to this to just kind of round off all of our all of the force powers that we're producing. And then sometime next week, probably Monday, we're going to make a video on creating a force power bar so that we can't just infinitely use these force powers. We're going to be restricted. And so on Wednesday, the force pull video will release, and then Friday we'll have the force choke. So I'll see you in those videos. If you want the assets for this video, check out the link in the description. If you have any questions, head on over to our Discord server. If you have any other ideas for force powers you want to see, leave them down in the comments. This is going to be a series that we continue into the future. Some ideas I have, for example, is a force healing and force lightning. So those videos are definitely coming. But if you have any other ideas, please let me know. And I'll see you guys in the next video.